Okay, so this is my calculus final. We're gonna do a quick tutorial. And if I was smart, oh dear, I forgot my pen, I would have started over there. So, the 5 things we're gonna go over are limits, derivatives, antiderivatives, the area under the curve, and volume. Because they're all related. And because I'm awful at calculus, we're gonna go easy. And this is our equation. 4x cubed plus 5x squared plus x. This is it. Okay, so I've begun setting up some stuff over here, right? Okay, so there's our equation again in case you've forgotten in these 2 seconds. And we're going to try to find what the limit is as x approaches 0. So what that means is as this number right here gets closer and closer to 0, what is it going to be? Now usually what you could do is take x and plug in 0 itself. But we're going to pretend that we can't do that for this equation. So I set up this, which if I was smart I would have filled out before. Frick. Okay, now that I've actually done this, as you can see, we have really tiny negative number getting smaller, kill me, smaller and smaller as you get closer to this 0 mark, and then over here we have really tiny positive number getting smaller and smaller as we get closer to the 0 mark, which means that as this equation, the limit as x approaches 0 for this equation is 0. It's an awful 0. Point is, that's what it is though. Okay, going back over here, erase. Yes. Okay, blank slate. Okay, now, derivatives. For our equation, 4x cubed, 4x cubed plus 5x squared plus x. Now, derivatives are basically, for this equation at least, what we're going to do is we're going to take this number right here, bring it down in front, and multiply it times that number. But then take this number right here and subtract 1 from it. And then that's how we'll have our derivative for this. This is the easiest form of derivative. It's the power rule. Yeah, I'm going with power rule. So, 3 times 4 equals 12. Keep our x to the second. Plus 5 times 2 is 10x. And then it's minus 1, so this is nothing there. And then plus, to take the 1 down in front, it's still 1. Shocking. Plus 1. And x is gone, because x minus 1 to 0, it's nothing. Well, actually, it's 1, but that's not important. So, doing this, that is now our derivative. Hi, Hanky. You're now in my calc project. Are you happy? I'm sure. Okay, so that is how we derivative. Yeah, that makes sense. So, technically, no, I'll get into that later. So this is our derivative for this equation. Now, doing antiderivatives, what we would do is we'd take our original equation and we'd put a snake with scoliosis out in front of it. Yes, and it's not even well drawn. That's okay though. But then we put our equation here, 4x to the third plus 5x squared plus x. So what this is going to do is we're doing the derivative except in reverse. So we have to add 1 to this. So it's going to end up as x to the 4th, right? But then we have to pretend that we didn't multiply this out in front. So we're going to take our new number here and divide it by our old number here. So it's going to be 4 over 4, which equals 1. So this is just going to be x to the 4th. And then we're going to add it, because we have no negatives in here, because I'm brilliant. And then we have to take it, so it's x to the 3rd. Oh, that's an awful 3. Not better. It's going to be 5 over 3. So it's going to be 5 thirds x to the 3rd. Go away, little thing. Then, for our last trick, we have x, but it's going to become x squared, because we're adding 1 to this imaginary 1 there. It's not imaginary, I just don't feel like writing it in. So we have this, and then it's going to be 1, because this was a 1 out in front, up here, 1 over 2. That's not square root, it's fraction. I know what I'm doing. Yes, and that is how we antiderivative. Now, in terms of this equation that we've just made, derivatives, we have f prime, and f double prime, or f prime prime, whatever you want to call it, really. I go with prime prime because it makes me laugh more. So we have f prime, and f double prime, right? And in the terms of this equation, our f would actually be our highest most equation, you know, like tiers, would actually be this, our antiderivative equation, because it is the least derivative. Then our f prime would be our original equation, that one, and then f double prime would be the one that has been derivative twice from our original equation. So we have f prime, f double prime. Yes. Okay. So I don't know if I want to erase those. I will. We're so high tech in here. So high tech. Okay. But then we have area under the curve, which uses our antiderivatives. That one. Yes. Okay. So using our area under the curve. Oh my God, I need Hanky. Does he have his calculator? Oh, I need that. Okay, we're back. Hanky is giving me his calculator because, like the fool I am, I turned mine back in before I was done with my calc project. Where was I? Area under a curve. Okay, so area under a curve uses our snake with scoliosis. See, it's right here. So we're going to say that we're going to try to find the area under the curve for our equation. Refresh our equation right here. There it is. We're going to try to find the area under the curve for our equation for x squared plus, that's a cubed, I know my life, plus 5x squared plus x, from, Hanky, give me two numbers to go from. 0 to 10. We're going to go from 0 to 10. 0 to 10. So what this does, if we were going to use an estimate, kill me. If we were going to estimate, what we would do is we would take the antiderivative, which we did, but I erased like a fool, which was 12x 4. I am a fool. It was not 12x squared. Genius. It was not. It was x to the 4th. I'm trying to like combine my derivatives and my antiderivatives plus x to the 3rd, 5/3. It's very hard to hold this phone when there's some filming on, plus, right, and still film. I'm bad at this. I'm so sorry. Plus, right, x squared to the 1/2 there. Okay, yeah. We're going to use this equation, our antiderivative equation, because we have the antiderivative symbol. So, what happens is this is technically not complete, because if we're antiderivativing, that means that there's actually another piece right here that we're missing. And that piece is known as plus c. So, in order to find that plus c is where we find the exact graph of our antiderivative. So, what we do is usually they give us something. So, in this case, I'm going to go at f of, I don't know, 4, it is equal to 3. Yeah, sure, I know what I'm doing. So what that does is it means that to find our c, we're going to plug in our 4, our x right here, into all of these x's plus c, and then set it equal to 3, because that's what it would be at this certain points, right? And when we do that, God, I wish I'd given myself more room. I need a chair. I'm too tiny for this. Okay, we're going up. Okay, so if we had that, then it would be 4. Hanky, can you plug this into the calculator while I do this? Thank you. Because I'm not a bright person. I did not think ahead. 4 to the 4th plus 5/3. 4 to the 3rd plus, I am about to fall over, 1/2 4 squared plus c. Okay, I need to move the chair over. God, I'm so tiny. Equals 3. Now, all those are now a number. That is not, and the 3's thing. So, plugged in.
Your c is the second thing.
What?
Your C is equal to negative 367.
Thank you. Okay, our C now equals negative 367. There are decimals, but I'm going to leave them off for right now because I don't like them. So, our antiderivative equation is now, I'm going to write it over on this board so I don't forget it, is now x to the fourth plus x to the third 5/3. You think I'd be better at this? I am. It's just doing two things at once is murder. Plus x squared 1/2 minus 367. Okay, so this is F. That's F now. Oh dear. F. Okay, so that's our F equation now. So going back to here, we have our area under the curve. So with that being our full equation, with that being our full equation, now we have to plug in our 0 to 10, right? So we have, if I could remember this equation for once in my life, that would be great. So we're going to take 10 to the fourth plus 5/3. I know what I'm doing. 5/3. 10 to the third. Chair in my way. Plus 1/2 10 to the squared minus 367. Now, usually we'd have this all over in brackets. If I could make a bracket, right? And then we'd subtract the one from our lower bound. Our lower bound in this case, though, is going to be zeros. So since all these 10s are now zeros, this is going to be 0. This is going to be 0. This is going to be 0, which means we're just going to subtract 367, but it's going to be negative 367, which means these are now positive. So we're going to add 367 to the end. For this, yes, very much so.
11,716.
11,716.
0.7.
What?
0.7. No.
Oh. I'm not good at this. Thank you, Hanky. This is the area under the curve of our antiderivative. If we're doing physics, that would mean that this is like the amount of distance it's traveled or something. Yeah, this is it. I'm gonna... Fancy. Okay, so going back to the other thing. Now we have volume. Volume is where we are actually we are rotating things, which is nightmarish. It's just nightmarish. So what we do for volume is, oh, there we go. Haha. I know what I'm doing. We have our volume. So we're going to take our antiderivative, right? So what volume is basically saying is we have our graph here, and we have a graph. I know that's not our graph, but we have a graph. Now, if we were to take our graph from like this angle, and we were to take it and we were to loop it around, then we'd be finding the volume of what this makes, right? That's what we're going to try to do. We're taking the 2D, turning it into 3D. Not my best model I've used, but not my worst either. Okay, so what we have to do that, though, you can see that as this loops around, it's going to make a circle of some sorts. Whatever type of circle it makes it. So that means that we have to... Oh, let me erase this. I can do this. Haha! I just found out that if you click the button, it erases, and I was so happy when I found out. No, so to do that, though, we need to use the area of a circle, which is the equation of the area of a circle. Please. There we go. Which is pi r squared equals a. So that's our equation of a circle, right, to find the area. So in order to do that, we need to slap a pi out in front, because it's a constant. It's not going to do anything, so we're just going to put that out there. And we're still going to keep our bounds from 0 to 10, and then we're going to write in our equation, which is, as always, 4x cubed plus 5x squared plus x, right? We have our thing. Oh dear, I forgot the dx on the integral earlier. Can't go back now. Okay, so we have this, but then we need, so this is our r, because this is how much it's going to be at any given point. So if we have our graph right here, like here's a radius, here's a radius, here's a radius, but that follows along because the integral on our boundaries. I know words. So what we're missing right now is this, because all of this is going to equal the a, but we're missing our squared. So what we have to do is put parentheses and a squared. Because, yeah. And then we have a dx, because x is, that just means we're going to be taking part of the integral. And that defines our variable in this, which is x. Yes, so then if we do that, we're going to do the exact same thing we did previously, where we take this and we plug in the 10, and we take this and we plug in the 10 and the 10, the antiderivatives, we're going to have it all squared, we're going to throw pi out in front of all of it, we're going to do the 10 and then the 0, and then that does nothing over here except square, and yes. You got me? You're in very high definition if it helps.
Sweet.
I know, right? Phones. Fascinating. And it's a lot of writing, and I tend to have very large writing already, and I've taken up the majority of the board. My hand's shaking. My arms are weak. Pi.
Gigantic.
I figured. I probably did not pick the greatest equation for this.
9.490
times 10 to the 7th. Okay, you should be ashamed, first of all, as a chemistry student, putting that many figures after the decimal, but
We have no data.
it matters to me. It matters to me. My God, did you see Tabitha misspell? Okay, that I'll talk to you about that later. She misspelled something in the yearbook. But we have this. This is the volume of the solid that this equation would make if we rotated it around the x-axis. And that is all I have to teach. I am now free. Goodbye, Miss Lawson.